My name is Dr. Chris Chase from South Dakota State University. I have been in South Dakota State since 1992. I am a veterinarian and I have my graduate degrees in immunology and virology, and I've been actively involved in cattle research, both in beef and dairy, for the last almost 30 years. One of the things that we're beginning to understand now is really the importance of the microbiome to immunology. So it used to be that we kind of thought what went on in the gut or in the respiratory tract was sort of independent of how the animal's immune system actually reacted. What we begin to understand now is that the two are very closely linked. And probably our first hint of that was looking at animals that are gnotobiotic, which means animals that we raise that are germ-free. And we look at those animals and look at the development of their immune system, it's pretty clear that, in fact, their immune system hasn't developed very well at all. So it becomes really important then that animals have the right exposure. And that's where the trick really comes, because we know that a lot of things affect both immunity and the ability of the microbiome to develop. And particularly, we know nutrition, the age of the animal, the different stresses that we have on it, for example, weather stressors, particularly heat stress, and cold stress certainly can have an effect as well. And things like dehydration is a big factor, because for the immune system to do what it needs to do, one thing is cells need to be able to move from one place to the other. And the other thing is that probably one of the things that we've kind of minimized over the years is the importance of the barrier itself. So whether we're talking about the lining of the intestinal tract or the upper respiratory tract of the animal, those are all areas where if we can do a really good job in terms of making that defense even better, it's really going to decrease the likelihood that that animal is going to get sick. So that's really, I think, as we looked at immunology when I first started, we looked at, well, we're going to use a vaccine, and the vaccine will make the animal be resistant. It's sort of like turning it into super cow. When in fact, what we know now is that the animal itself has to sort of sense what's going on in its environment through its microbiome, through those bacteria, viruses that are its intestinal tract and its respiratory tract, to help sort out what it needs to do in terms of actually having a good immune response. And we know, again, that if we don't do a good job in terms of nutrition, or we don't do a good job in terms of hydration or minimizing stress, that regardless of how good a vaccine program that we have, or how good of biosecurity, or our ability to keep bugs out, that in fact those animals are still going to be much more susceptible to disease, and probably more importantly to the producer, less likely to be as productive. So they're lean, gain will be lower. If it's a milk cow, her milk production will be lower. The reproductive status of the animal will be less. So these all end up are costs that kind of creep in that affect the overall ability of that animal to be productive, and obviously that farm enterprise, this ability to be effective and to make money and to provide the standard of living that family needs on their farm. So again, to me, it's understanding how we can then take things like prebiotics and probiotics, because I think we're all aware of that there's going to be a decreased use of antibiotics. That's a pretty clear trend that we're seeing, and I think often for good reason that we're seeing that occur. Oftentimes, antibiotics were used kind of as a Band-Aid to make up for poor management, and what we need to do is be, I think, very proactive in using nutraceuticals like probiotics and prebiotics, in terms of being able to use them prior to what the stress is going to be, prior to the event that we're trying to help that animal get through, to make them even better in terms of helping that animal, again, be more productive and less likely to develop disease. So one of the things that we know when it comes to stress in the immune system is that stress can actually behave in two ways. So oftentimes when people would talk about stress, they talk about being suppressive. So in other words, the animal's immune system doesn't work as well, and that's certainly true. But I think what we've discovered more times than not, the first thing that happens is that immune system actually over-responds. And in the case, for example, if we have animals that have been under heat stress, that's one of the times that really the immune system is already kind of on edge. And then so that if we come along and we vaccinate those animals or we handle them extensively, we just push that stress level a little bit even higher. And we refer to that now even as immune dysfunction. That means that the immune system is sort of totally out of whack. And either could be, so it can go from a high where it's doing too much to all of a sudden going clear down to a trough where all of a sudden the animal's not responsive at all. And stressors do that, and we know that they can be additive. So that's why trying to break those opportunities that we have to work with animals or to do different activities up as much as we can. So for example, castrating and vaccinating right after transporting the animals is going to be a lot of a very hard stress on that animal and on its immune system, and the likelihood that it's going to respond to vaccines with those additional stressors is going to be pretty low. And if their cattle come from a sale barn or they've been commingled from several different groups and then we vaccinate them and they've been dehydrated, all those things together are going to cause that animal, then its immune system to be less functioning and that animal to be more prone to either not responding to the vaccine, being less productive, or even worse, becoming more ill or having more acute disease and increasing our morbidity and mortality. The importance of the microbiome, again, is one of those things that we've just been able to elucidate over time in terms of what it means to the immune system. So certainly one of the things, like I said, that we understand is that if animals are in a system where they're not exposed, so again, no antibiotics, where they're not exposed to any microorganisms, their immune system just doesn't develop very well at all. And we know then that as they're exposed, and this is sort of the interesting thing that we're seeing with human health, where we're sort of doing everything possible to do all the hand washes and actually have less exposures, I think it actually makes it more likely that we're going to become sicker rather than more healthy, because those exposures are important to helping the immune system sort of fine-tune itself and keep itself sort of up to date in terms of what's going on. So by those exposures that we have, particularly in this case in the intestinal tract, what it's going to do is it's going to enhance the barrier. It's going to make that animal more efficient in terms of its productivity. And again, if we then do something, so if the animal's on a long haul, we have a big diet switch, and all of a sudden in that case, really mess with the microbiome, so we really change it, then that's when that animal is going to be much more likely to be at risk in terms of developing disease and certainly being less productive. So being able to manage the animal, manage the stress, and again, and I think one of the things that I think has become that's important when we talk about nutrition isn't just what the requirements are for that immune system, but they're also the requirements of what we need to do to maintain a good microbiome. One of the things that we have learned, again, is that we've had antibiotics were first, certainly the ones for feed efficiency were all about trying to enhance I think really the health of the gut, and they did it in a way that I think to this day we're still not exactly sure how that worked. But what we know now, as we've begun to look at things like prebiotics and probiotics, we're looking there we can demonstrate in terms of the production of molecules that we know have a positive effect on the gut in terms of either enhancing the better tight junctions so that we don't have a leaky gut, or we have the increase of our barrier, that kill zone, so that the animal is more well protected in the gut. We've seen that these types of products can do that in organic acids in terms of how they change the pH, which then changes the kind of bacteria or viruses that might be in one part of the gut. All of these have their place. And I think, again, we're going to learn to use strategies where it's going to be a combination of these. And it will be really dependent on the stress on the animal, the age of the animal, the production setting that the animal is in. But we're going to be using those in a very strategic way, again, to help, hopefully in most cases, to be ahead of problems. But also, I think there's a therapeutic basis for these as well. But again, they help us in terms of enhancing that overall, the gut health and then that animal's immunity, because gut health and the animal's immunity are tied hand in hand. So leaky gut, we know that, and again, a lot of the work that's been, I think, done particularly at Iowa State has sort of looked at trying to identify different stress factors, but we certainly know that changes in feed, that stressors, particularly heat stress in particular, commingling, are all factors that I think, for the most part, what they do is they affect the overall the barrier function of that animal. So if we're talking about heat stress, in that case, we have less nutrients going to the intestinal tract, so the goblet cells have less ability to make mucus. There's less anti-inflammatory cytokines that are there. And so when it comes to the leaky gut, there's really two major things that happen. You have a breakdown in the barrier. So if an animal is dehydrated, that barrier is going to get thinner. We may have some of the important things like antimicrobial peptides not being produced. And then the second point of that is that the tight junctions themselves begin to break down. And then that allows a direct conduit then for not only bacteria, but even feed materials to actually go across the gut, and they are inflammatory. The immune system sees those as a danger. It responds to them. And the thing about the immune system, particularly the innate immune system, is sort of all or none. So when it sees a danger, it's going to go in there and give it its best to get rid of it. But unfortunately, its best can often be too much. And so by being able to, again, minimize leaky gut, we end up we'll have less damage. And with less damage, then what we'll have is we'll have more energy going to growth and production and less into repairing and into things that are not associated with lean and growth or milk production. So being able to minimize leaky gut, and again, so it begins with a lot of management factors are really involved with that in terms of trying to minimize that. So again, as I said, dehydration being a huge part of that, drastic feed changes, animals being off feed, are all big things that have a major impact on that. And then commingling animals is another thing that certainly has a big effect. And weaning, and certainly parturition. So an animal that has just calved, in terms of their intakes, are much different. And so we have to be aware of those as well. So we're going to need to try to, as much as we can, try to minimize multiple stressors at those different important control points.